Welcome back, guys. Today I'll be doing another activity where I'll be showing that this is a unitary matrix. Let's get started. So here I need to show that matrix A is a unitary matrix. Now it's a 2 by 2 matrix. So I'll be using I for my imaginary number. So if I have I square, then we know it's going to be -1. So this is my 2 by 2 matrix, 1 over root 3, 1 minus I over root 3, 1 plus I over root 3, and the final one we have is -1 over root 3. So this is my 2 by 2 matrix, and I'll be showing that it's unitary. Now, just a reminder, what is a unitary matrix? A asterisk represents a conjugate, and then transposing it, when I do this, it must be equal to the inverse of the same matrix. So I'll be doing the conjugate, then the transpose, which is the left-hand side. Now, the conjugate means changing the imaginary number. So where I have plus and this minus, I will be changing it. But these are real because there is no I on it. So finding the conjugate, I will have just 1 over root 3 because this is a real number. There's no imaginary number. Next, what I have is 1 plus I will be changed to 1 minus I, the conjugate, over root 3. Then the next one, I need to find the conjugate of 1 minus I, so that's 1 plus I over root 3, and then we have the -1 over root 3, which is a real number. Now, I am going to find the transpose of this. The transpose is changing the rows into columns. Others will say columns into rows. So here I have my first row. I will change it to a column, so I have 1 over root 3. And then this will be 1 minus I root 3. So the first row becomes our first column. The second row will become our next column. So I have 1 plus I over root 3. And then the next one I have -1 over root 3. So this is the first part, which is the left hand side. Now the next side is where I will find the inverse. The inverse of the 2 by 2 matrix. Let's remind you, what is the inverse? Let's have a matrix A, B, C, D. Matrix A, B, C, and D. I will find the inverse. So the inverse of this matrix, I am going to have 1 over the determinant, so AD minus BC, so B times C, times the adjoint. The adjoint is where I switch these two, and then I change the sign, so I have minus B and minus C. Now, we are going to find the inverse of this matrix. So we have 1 over, we're going to find the determinant, but I will find it over this side. So I have, the determinant is AD minus BC. Let me label matrix A. So I'll have A, B, C, D. So determinant is AD, so it's 1 over root 3 times -1 over root 3. And D is a -1 over root 3 that I have here. BC, so I have 1 plus I over root 3 times 1 minus I over root 3. Now multiplying here, the numerator together and the denominator, 1 times -1, that's -1. Root 3 times root 3, that's 3. In the numerator, we have the two complex numbers to be multiplied. So 1 plus I times 1 minus I can multiply 1 times 1, that gives me 1. 1 times minus I, that's minus I. And I times 1, that's I. That will cancel. I times I again, that's I square, and we have our sign. But I square is negative 1, so this will change to a positive 1. So what I really have is 1 plus 1, and that gives me 2. So in other words, the expansion for this is 2 over root 3 times root 3, that's 3. And then minus 1 minus 2, that's minus 3 over 3. And this will give me negative 1. So in other words, here I'll have minus 1, and the next part is where I will have the adjoint, and the adjoint means I switch AD, so I'll have negative 1 over root 3. I'm switching the positions, so I have this, and then change the signs of the next two, so this becomes minus. So I have minus 1 minus I over root 3. The next I have 1 being changed to negative, so it's minus 1 plus I over root 3. And this is the same as negative 1. So when I have negative 1, everything changes. So changing the signs, so what I will have is 1 over root 3, so this will become positive. And the next one I'm going to change, so I have 1 plus I over root 3. And then here I will have 1 minus I over root 3. And then the next one I will have minus 1 over root 3. So here we have A inverse. You can see it's the same. The left and the right are the same. So I can say it is indeed a unitary matrix. So matrix A is an unitary matrix. And that's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have more questions, leave a comment below. Have a great day.